Suppose we're given the problem of graphing the equation negative 4x is equal to 3y plus 12. Well, how we do that is really coming back to the Euclidean postulate idea of that between any 2 points there is a unique line. And so if we just had 2 solutions to that particular equation, we would be able to graph the line. So that's exactly what we need to do, and that sounds great and wonderful, but then we ask ourselves, okay, exactly how do we go about doing that? Nobody's given us any x values, nobody's given us any y values. And so we can say, exactly how do we go about doing that? Well, the answer is really kind of implied if we look at how we did the x-intercepts and the y-intercepts, or how we did completing the ordered pair in order to make a solution. That gives us kind of maybe a little implied way of knowing how to go about this. Now, our strategy for doing this is to really, our first step is to choose one of the variables in the equation and to choose a value for that variable. Now, that may seem just a little bit strange because, and maybe a little counterintuitive for how most people tend to think of mathematics. The mathematics is really just a bunch of rules that people need to follow, and in this case, that's not necessarily true. That we have the freedom to choose any variable that we want, and we have the freedom to choose any value for that variable that we want. Now, the second step is to substitute into the equation the value that we chose for the variable that we chose. And then finally, our third step is to solve for that unknown variable to get the value of an ordered pair. So let's see how this might work. To begin with, let's make an arbitrary choice that y is going to be 3. Well, if we go back to our original equation, our negative 4x is equal to 3y plus 12, we plug in 3 for y, and so we obtain an expression negative 4x is equal to 3 times 3 plus 12. Well, if we simplify that a little bit, we get 3 times 3 is going to be 9, and then our 9 plus 12 is going to give us 21. So that we have the equation negative 4x is equal to 21. So how we go about solving that is to divide both sides by negative 4. And in doing that, we obtain a solution that x is going to be negative 21 over 4. And so what that does is to give us an ordered pair of negative 21 over 4, comma 3 for our value. So in doing that one more time, let's choose again and now make an arbitrary choice of x is equal to 4. So coming back to our original equation, we plug in 4 for x, and then in simplifying that, we have negative 4 times 4 is going to give us a negative 16 is equal to 3y plus 12. Now it's at this step that we have one equation with one variable that we need to solve. And so in solving that, what we need to do is to subtract 12 on both sides. So we have minus 16 minus 12. Then the minus 16 minus 12 is going to give us a negative 28 on the left. And on the right, the minus 12 cancels out with a plus 12, just leaving us with a 3y. Now if we take and divide both sides by 3, then we obtain a value of negative 28 over 3 for y, and therefore an ordered pair of x being 4 and y being negative 28 over 3. So the question becomes, where does this exactly fit in with the idea of completing an ordered pair or finding the intercepts to an equation? Well, the problem is that in each one of those steps, the writer has actually gone in and taken away your freedom from step 1. And so what we need to do, and to kind of see how that works, if we are completing an ordered pair, such as they gave you 3 comma something, then what happens in that situation is they have actually said, oh, we're going to choose x to be 3. In finding the x-intercept, they're choosing y to be 0. In finding the y-intercept, they have already chosen that x is going to be 0. And so in each one of these situations, they are actually kind of circumventing step 1 in taking away your freedom of choice for the variable and taking away your freedom of choice for the value for that variable. And so the danger that we have of this choice is that sometimes in choosing, we don't necessarily get pretty answers. And so we could go back and actually check that our answers really do in fact give us true solutions. And we could do that by actually plugging into the original equation. So if we took our first ordered pair of negative 21 over 4, comma 3, plug that in, our x value is negative 21 over 4, our y value becomes 3. 3 times 3 gives us 9, and so we have on the right hand side 9 plus 12. On the left hand side we have negative 4 times negative 21 over 4, which gives us a positive 84 over 4. 84 divided by 4 gives us a 21 on the left hand side. 9 plus 12 gives us 21 on the right hand side, a true statement, and therefore we have a solution. For the other ordered pair, if we plug in 4 comma negative 28 over 3, our x value becomes 4, our y value becomes negative 28 over 3. So on the left-hand side, we have negative 4 times 4, which gives us a negative 16. On the right-hand side, we have 3 times negative 28 over 3, which gives us a negative 84 over 3. And then we have our plus 12. Negative 84 divided by 3 is a negative 28, plus our 12 that we already had. Negative 28 plus 12 gives us a negative 16 on the right-hand side, a negative 16 on the left-hand side, a true statement, and therefore we do in fact have another solution to our equation. And so what would have happened had we actually chosen the x-intercepts and the y-intercepts? Well, for the x-intercepts, we make y 0. So taking our original equation and plugging in 0 for y would give us a negative 4x is equal to 3 times 0 plus 12. Well, 3 times 0 is going to give us 0. And so that simplifies to the equation negative 4x is equal to 12. Now, what this actually does is we divide both sides by negative 4, and to give us a value of x is equal to negative 3. And so our ordered pair becomes negative 3, 0. If we wanted to find our y-intercept, we again make x 0. So plugging this in to our equation, we have 0 is going to be equal to our 3y plus 12. Well, if we subtract 12 on both sides, then that's going to give us a negative 12 is equal to 3y. Divide both sides by 3, and so we have a value of negative 4 is equal to y. And so that gives us an ordered pair of 0, negative 4, which in this case we do have nice answers for those values. So now if we go over to Geogebra, let's see what the graphing program actually gives us. So if we plot our x-intercepts and our y-intercept, we had our x-intercept of being negative 3, comma 0, and we had a y-intercept of 0, negative 4. Now we also had two other points on there that we found as part of our choices, and one of those was going to be negative 21. So negative 21 over 4 comma 3 was one value, and our second point was 4 comma negative 28 over 3, which shows up if we zoom out a little bit, and there are 4 points. Well, if we draw the line through our x-intercept and our y-intercept, what we see is that, yes, we do in fact end up with an equation that Geogebra gives us is pretty similar to the equation that we started with. We started with the equation negative 4x is equal to 3y plus 12. Well, we can see that if we kind of rearrange those terms a little bit, we can obtain the same equation that Geogebra gives us. And so we know that for our x-intercepts and y-intercepts, that gives us the right answer. Something that we also notice is that the points which we found, point C and point D, which are also solutions to the equations, do show up on our line that Geogebra gives us. Now, where you have to be a little bit careful with technology and just choosing your points is that sometimes technology will mess up just a little bit. And here's where I can show you that Geogebra does just that. If I select the points C and D and draw the line through C and D, I'll see that the equation which Geogebra gives me is not quite the same equation as I had passing through those two other points. Now, the reason for that, if I zoom in on the value for point C, we see that yes, negative 5.25 is the true decimal value of negative 21 over 4. Whereas, if I try to go down here and zoom in on the point D, which was supposed to be my 4 comma negative 28 over 3, here I see that my decimal is only negative 9.33. Now that's an approximation for the fraction negative 28 over 3, but it's not the actual true value. And so, because the computer is not actually able to plot that true value, I get an approximation, and so the line which Geogebra calculates between those 2 points is not the right equation, and it's not the right equation simply because Geogebra wasn't able to plot the point that I chose. But going back through the algebra, we know that both of those points, my negative 21 fourths comma 3 and my point 4 comma negative 28 over 3, both of those are solutions because we checked them algebraically. And so this shows that sometimes technology is somewhat limiting in what we're really able to do with it whenever it comes to mathematics and numbers. Now, sometimes for some graphing software, if you're doing this, they may actually limit you to particular values for X and Y that you're able to put in so that you do get nice answers.